everybody. In this week, we're going to be talking about three-dimensional measurement. So, when you're reading through your case studies, you're going to see some examples of situations where students are learning how to differentiate between two-dimensional versus three-dimensional measurements. And also, you'll see an example of how one teacher decided to develop the concept of volume for rectangular prisms. So, those are some of the themes you'll see in the case studies. And then for your video projects, you guys are going to explain why the volume formulas for cylinders, cones, pyramids, triangular prisms, and hexagonal prisms work the way that they do. And then on your homework, you're going to be finding the volume of some complex three-dimensional shapes that you need to like split up into pieces to be able to find the volume of them. And then you're also going to practice drawing some three-dimensional shapes. Because oftentimes when you're teaching, you need to like be able to quickly sketch out a diagram, and knowing how to draw three-dimensional shapes can be helpful because often it's really difficult to like draw a two-dimensional representation of something that is three-dimensional. So I'm going to show you guys really quick how to sketch those out quickly because that can be a useful skill when teaching geometry. So this lesson is a kind of like the last lesson in our measurement section because we talked about how to measure one-dimensional lengths like perimeter in week 2. And then in week 3, we talked about area. That was last week, where we learned how to measure two-dimensional space with square units. And three-dimensional measurements are where we use cubic measurements to find the volume. So remember that a three-dimensional unit is one that has 3 units that are all perpendicular to it or to each other. So like, for example, a cubic inch has 1 inch along each of these sides that are perpendicular to each other. And that's what makes it a cubic inch versus a square inch just has 2 inches that are perpendicular to each other. And that's why it's called a two-dimensional measurement or a square inch. So that's just a quick reminder of the units and how they're related to each other. And when you're finding the volume of a rectangular prism, if you're first introducing this to students, one of the best ways to do it is to give them a real world problem. So maybe you have a tissue box in your classroom and you say, okay, I want you to think about how you would find out how many cubes we can fit into this tissue box. And maybe you have those little like 1 inch cubes that like, I don't know what they're called, but they're like little cubes that you can like stick together. They're like counting blocks or something like that. But you could have some type of cube that you have a lot of so that you can fill up this tissue box. Or you could also have like a smaller box, like a little one, and then have them use base 10 blocks, which are usually 1 centimeter by 1 centimeter by 1 centimeter. So they're cubic centimeters. But whatever shape you decide to use is fine. But just have some type of rectangular prism and have cubes that the students can use to figure out how many cubes fit inside the box. And when you do an activity like this, some students are going to like just fill up the whole box and count all of the cubes. Other students will have a more systematic approach where maybe they figure out how many cubes go in one layer along the bottom, and then they just add those together for however many layers tall the box is. So there's lots of different strategies, but if you let the students experiment with it first, then when you teach them the formula for the volume of a rectangular prism, it will make a lot more sense. Because the way that the formula works is that the volume is calculated as the length times the width times the height of the prism. And the reason why this formula works is because when you do the length times the width, you're basically figuring out the number of cubes in the bottom layer or the top layer of your box. So I'm going to look at the top layer just because it is easier to see in this drawing. So when you take the length, which is 5 units, and you multiply by 2 units, you're basically saying that since I have 5 cubes in one row of that layer. If I multiply by 2, because that's the width of this rectangular prism, then I have 10 cubes in the top layer of my prism. And then you multiply by the height because you have 3 layers of those cubes. So, you have your top layer, your middle one, and your bottom one. And so in this case, you multiply by 3 because you have 10 cubes in each of the 3 layers. And so that's how you would find the volume of this rectangular prism. And because multiplication is associative and also commutative, you can actually do this multiplication in any order. Because if you calculated this as the width times the height and then multiplied by the length, it would still be the same answer, because what that's doing is essentially when you do the height of 3 multiplied by the width of 2, you're finding the number of cubes in this layer of the rectangular prism. And then when you multiply by the length, you're saying that since I have 5 of those layers that each have 6 in them, then I have a total of 30 cubes. So you can multiply it in that order, or you could also calculate it as the length times the height times the width. That would also work, because if you do 5 units times 3 units, that's finding the number of cubes in this front layer, and then multiplying by 2 because you have like 2 layers. And so when you're discussing this with your students, you can ask them like if it's possible to multiply in any order to find it, and help them see that it doesn't matter which layer you find first. You just need to figure out how many cubes are in one layer and then multiply by the number of layers. And when you do an activity like this can really help the students understand the meaning behind the volume of a rectangular prism, which is a core concept for all of the following volume formulas they'll find. Because a rectangular prism is the easiest shape to find the volume of. And so you really want to make sure that they understand this concept well before they move on to finding the volume of other prisms. So on your guys' homework, for some of you, those of you that are assigned these video projects, you'll be finding the volume of other prisms. So you may find the volume of a triangular prism or the volume of a cylinder. So a cylinder is not technically a prism because it has a curved surface, and prisms only have flat surfaces. But the concept is very similar. Because a cylinder is kind of like the circular version of a prism. Um, and so when you're finding the volume of other prisms that are not rectangular, the key here is to figure out how many cubes can go on the bottom layer, where the bottom is the part of the prism that kind of like doesn't make, how do I explain this? It's the base of the prism. That's the formal name of it. I was trying to think of a non-technical way of describing it, but basically like um the shape that's on both the top and the bottom of the prism. Even if the prism is oriented sideways, like this one is a triangular prism because it has a triangle on the top and the bottom, but this triangular prism has been oriented so that it's actually like the front and the back of the prism. But if you were to orient it a different way, it would be like the top and the bottom. So the technical name is that it's the base of the prism, even if technically it's not on the bottom if it's oriented a different way. So basically, the idea is you figure out how many cubes you could, like if you oriented it so that the base was like on the bottom, how many cubes could you fit on that base? And then once you figure out how many cubes are on the base, which is also equivalent to the area of the base, because remember, area is a two-dimensional measurement that measures how many squares um, are on a two-dimensional surface. But that would be the same number of cubes in like on one layer, because the cubes could all be placed on those two-dimensional squares. And so once you find that area of the base, then you just say, okay, well, how many layers of that do I have? And you multiply by that to find the volume of the entire shape. So the volume for a cylinder will be very similar, where you'll figure out how many cubes it would take to cover the bottom of the base of the cylinder, and then you figure out how many layers of those cubes you would need to fill up the entire cylinder. Um, so that's a little hint for those of you that are doing the volume of prisms or cylinders. And for those of you that are finding the volume of a pyramid or a cone, or if you want an extra challenge, you can do the volume of a sphere. For those of you doing those, the key concept here is to um, essentially like find a three-dimensional shape that's easy to find the volume of, and then find out what fraction of that shape it will fill. So, for example, if you have this square pyramid here, one way that you can find the volume of that pyramid is to find the volume of the rectangular prism that it fits inside, and then it will be a fraction of that because it's only filling up part of that rectangular prism, but not the whole thing. And so this is very similar to the concept that we talked about last week, where you can find the area of a triangle by finding the rectangle it fits in and then saying that the triangle is half of that rectangle. And because this is a three-dimensional shape, the fraction will be a different fraction, so it's not going to be half, but it will be a nice fraction of the rectangular prism that it fits inside. And for a cylinder, it's a similar type of idea because a cylinder, or sorry, not a cylinder, a cone, the volume of a cone will have a similar strategy because a cone is kind of like a circular version of a pyramid. So pyramids are ones that all have straight or flat surfaces, and a cone is not a pyramid because it's rounded, and pyramids don't have rounded faces. But the concept is very similar to the idea of a square pyramid, or really any type of pyramid, because you can also have triangular pyramids or hexagonal pyramids, depending on what the base of the pyramid looks like. So that's kind of the concept for how you would do those. And if you want to do the volume of a sphere as an extra challenge, that one is also going to be a fraction of the shape that contains it. So the easiest shape to contain a sphere would be a cube, because a cube could fit perfectly around the sphere. And then the volume of the sphere will be a fraction of the volume of that cube. So that's just a little tip for those of you that are assigned pyramids or cones on your video project. And the last thing I wanted to go over is how you can draw three-dimensional shapes if you need to sketch it out really quick on the board to facilitate a mathematical discussion. So first of all, I want to talk about how to draw prisms. So it depends on which way you want to orient your prisms. So the easiest way to draw a prism is to orient it so the base of the prism is like the front of the prism. So what I mean by that is, like, if I wanted to draw a triangular prism, I'm going to just draw the triangle that is the base of that prism. And then I'm going to draw that same triangle so that it's the same size but slightly offset. So this is going to be the back of the prism. And then from here, you just match up the corresponding vertices, I guess, of the triangle. So this is going to be part of my drawing, and this. And then you can often use dotted lines to represent the edge that you can't see. So technically, these two should also be dotted lines because you can't see them. But you still want to draw them because it helps the students visualize what the other side is. And I tell the students it's kind of like this object is see-through. So you can kind of see it, but you're seeing it through the prism, like through the object, versus just seeing the surface itself. So that would be how you would draw a triangular prism. And when you draw it, these lines should all be parallel to each other. If they're not parallel to each other, it's going to make your shape look like it's twisted and not like essentially not a prism. So always make sure that these lines are parallel to each other, and they also should end up being the same length. So sometimes when I draw prisms, I'll start off by drawing the shape. Like, for example, if I want to draw a rectangular prism, I'll draw my front face, and then I'll draw a bunch of lines that are all parallel and the same length that look like this. And then I'll draw the shape in the back for it. Now, this is not necessarily the best strategy because as you can see, my back shape didn't really end up looking like a square because I didn't make these lines exactly the same length. And so that's a good example of how your shape can kind of end up looking a little squampus if your lines are not parallel or if they're not the same length. And you can also orient this from another perspective as well. So like if I drew a rectangle here, and then I offset it over here, this would make it look like you're looking at the rectangle from a different perspective. Because if I connect all of these edges like this, you can see that it's kind of like looking at the box from a different angle. And whatever type of prism you want to draw, you kind of just draw the two shapes offset in whatever direction you want the perspective to look like. And then you connect them with those parallel lines. So that's how you draw a prism that's turned on its side. If you want to draw a prism that's like kind of like standing upright, then you have to draw the base of your prism with the perspective line. So if I wanted to draw a rectangular prism, I would draw kind of like a parallelogram because that's what a parallelogram that's sitting on the ground looks like in like a 3D perspective. And then once you've got that, then you can draw the lines that go up. So it would look kind of like this. And I didn't make them all exactly the same length, so I'm going to have to draw another parallelogram that looks like this to kind of make it look like that. And so this would be a rectangular prism that's more standing upright. And this one tends to be like maybe a little bit more challenging to draw because you have to think about what shape or like what it would look like on the base with that 3D perspective. So a good rule of thumb is just to do this method of drawing prisms. But if you want to, you can also experiment with drawing them upright because sometimes that's the orientation that you have. And this method is relatively easy for cylinders because you like a circle that's with that 3D perspective is just kind of like an oval shape. So you can draw like two ovals and then connect them like that to make it look like a cylinder. And again, technically, this part should be a dotted line to show that that side is kind of unseen or like you're seeing it through the shape if the shape was transparent. And similarly, these should be dotted lines as well. I didn't do all of those as dotted lines, but by making them dotted, it can help the students understand that that's like the back side of the shape that you're seeing through the shape if it was transparent. So that's a little tip on how to draw prisms. When you're drawing pyramids or cones, the idea is that you are going to draw a base, kind of in the same way that we drew the upright prisms or the upright cylinders. So, like if I wanted to draw a square pyramid, I would draw a parallelogram base because that's the like three-dimensional perspective of the square in 3 dimensions. And then you determine where the center of the shape is, and you draw a point that's up above that. And then you connect. So that's going to be like the tip of your pyramid. And then you connect that to all of the corners like this. And again, this is the unseen side. So that would be that side there. So that's how you would draw a pyramid. If you wanted to draw a triangular pyramid, you would draw a triangle and you would draw in perspective as well. So that kind of means it will look a little bit squashed. And then you'll find the center and maybe we'll make this a short pyramid. So we put a point right there and then we connect this to the sides and this would be a dotted line. And actually, I just realized that it probably, like, this is kind of like looking at the pyramid straight on. If you wanted to do the pyramid a little bit more from a different perspective, you could draw it kind of like, I think it would be like this. So that's looking at the pyramid from a different perspective. So on your homework, you can kind of play around with it and experiment with the different perspectives and how you can draw them. Um, and a cone is very similar in the sense that you'll draw a circle with that three-dimensional perspective, which is kind of like an oval shape. And then above the center, you put the tip of the cone, and then you just draw the sides of the cone. And you can make this a dotted line to show that that side of the cone is on the far side or the back side of the cone. And that's very similar to the way that you would draw a pyramid. And if you want to, you can also teach these methods to your students because it's one way that they can think through like the different features of a shape. Because if you're going to draw a pyramid, by drawing the base first, you're kind of decomposing the pyramid into that bottom face. And then by saying that this is the center up here, um, you're kind of helping them articulate the different components of that three-dimensional shape. So, if you feel like your students are up for this type of an art project, you can teach them how to draw three-dimensional shapes, which can also help them when they're trying to articulate their reasoning for various things, because they can actually draw an accurate picture of the shape. So I hope that this video was helpful and that you guys enjoy this module on volume. And if you have any questions, let me know.